Hi, today we will be discussing potential energy, which is part of a two-part series. The video following this would be kinetic energy. So let's get started. By the end of this lecture, you should know what is potential energy, what is the formula for potential energy, what are the units for potential energy, and how to solve for potential energy. So let's get started. Potential energy is the stored energy an object has due to its position. So this is the amount of energy an object has before it moves. So if we take a look at the crane here, with the ball, the wrecking ball it's attached, we'd be looking at the amount of energy stored in the wrecking ball before it is swung. Now if we take a look at the guy with the bow here, he has the bow string pulled back with the arrow knocked in the string. The amount of energy stored in the string is the potential energy available for the arrow to use when it's released. So looking at these two objects, we can see the potential energy is the amount of energy stored in an object before it moves. Now that we know the definition, we need to know a little bit more before we solve. So, potential energy has a little bit to do with the height the object is above the Earth's surface. So the higher the object is above the Earth's surface, the greater the potential energy the object has. So, right here we have a ball at the top of a hill. At this point, it has 50 joules of energy. As it moves down to this level, it only has 40 joules of energy because it's closer to the Earth's surface. As we keep moving down, it has less and less stored energy until it has zero when it's resting on the Earth's surface. So the higher up it is, the more potential energy it has. So now that we know what potential energy is and what is factors towards it, we can now solve for potential energy. So to solve for potential energy, we need to know three things. The mass of the object, and this is done in kilograms. The gravitational constant for Earth. So we need to know the Earth's gravitational level. And on Earth it is 9.8 meters per second. So it is a type of acceleration. And then the height the object is. And this is recorded in meters. So we need to know the mass, the gravitational constant, and the height the object is. So now that we know those three things are required, we can now learn the formula. To solve for potential energy, our formula is potential energy equals mass times the gravitational constant times the height. This can be shortened to PE equals mgh. PE standing for potential energy, M standing for mass, G standing for gravity, and H standing for height. So, now that we know the formula, let's take a look at another way we can figure out what we are solving for depending on our given information. And we've seen this triangle before. We've just added a new level because there are 3 or 4 variables in here. So on the top here, we have potential energy, and again, we have our formula, mass, gravity, and height. So let's say we are solving for potential energy. Our formula would be mass, gravity, and height. Now, let's say we were solving for mass. We would look at this, and we'd see potential energy, that mass equals potential energy divided by gravity times height. And again, this is what we would see. Now let's say we were solving for the gravity. Let's say we were solving for the gravity on a different planet. We know that on Earth it's 9.8, but let's say we were looking at Mars. So in order to solve for the gravity, it'd be potential energy divided by mass times height. And that's what we see here. So as you can see, this formula triangle is a great way to figure out how to rework our formula depending on what we're solving for. And again, we'll see it one more time with height. So if we were looking for height, we'd be looking at potential energy divided by mass times gravity. And that's what we have here. So now that we know our formula and how to use that triangle, we need to know our units. Now we had a preview on the other one, on the previous slide with the triangle, but potential energy has the same unit as work does. In fact, a lot of the energy that we're going to be talking about uses the joule, as we learned back when we were learning about work. So, now that we know the unit is joules, we can now finally solve. So, this is our example problem. What distance is a book from the floor if the book has a potential energy of 198 joules and a mass of 5 kilograms? So, this is a picture representing the problem. So what distance is the book? So we're looking for the height. 5 kilogram book has 198 joules of stored energy. So now that we got our information, we now write our chart and plug in our 4 givens into the given box: potential energy, mass, gravity, and height. According to the problem, our potential energy is 198 joules, so we're going to plug that into the joules box. Then it says our mass is 5 kilograms, so I'm going to plug that in for our M, our mass. And remember, I told us what our gravitational constant for Earth was 9.8 meters per second, so we're going to plug that in. Don't worry, you guys will get this constant on the formula chart for exam, but it's a good bit of information to know. You'll see it quite often. And then it's asking what distance is a book from the floor, so we're looking for our height. So if we look at this chart again, triangle chart, if we're looking for the height equals potential energy divided mass times gravity. So we write our formula, and then we pull it up into our workbox to make it easier when we substitute. We plug in 198 for our potential energy and divide that by 9.8, which is our meters per second, our gravity, and 5, which is our mass. Now, I put the parentheses in because it is important, so that way we do the correct order of operations. So the first thing we would do is multiply 9.8 times 5. That would get us 49. So at this point, we divide 198 divided by 49, and you plug it into calculator just like that. 198/49. And we'd get an answer of 4.04. So we take that 4.04, put it into our answer box, and attach our unit, which is the meter. So using this unit formula, we figured out our height of the book above the surface is 4.04 meters per second. So now that we've figured out how to use the formula and how to solve for energy, we are done. So you've learned what potential energy is, what the formula for potential energy is, what are the units for potential energy, and how to solve for potential energy. Thank you for listening. Now please watch the second video, kinetic energy, that follows this one. Thank you and have a nice day.